Oh, you know, make sure I don't know. Should I send the link? You know. All right, so I think I got a few labs from some persons, but let me see something. See, I haven't gotten from most though. So uh,
Lab number 7.
then
Lab number 7. We're doing today.
yeah, it more than likely. Let me see. Um, I'm trying to get some persons' attention about class, but not seeing it happening. Not seeing persons coming in.
Easter break now white, sir.
Was that? Yeah,
When
Easter break.
Easter break now white.
No, but but yeah, remember the same thing happened to you, you know. You remember say when time
No,
Easter.
sir. I remember, sir.
I mean, I see everything. You see, I see everything. Them no member neither. So they need to be reminded. I listen. All right. So I got this one. All right. So I go. All right. Trying to do some roll call, but persons I'm not in. Just have 9 persons now. That's 9 persons online. Definitely. Oh, okay, good. So SOS went out here, and I got one more person. Yeah,
Hi, sir.
yeah. Hi, Kimberly. All right, let's get this. Hold on a sec. I'm gonna see if I have everything. Is all right. Um, yeah. So yeah. All right. So we're into lap 7, but then um, need to point out something to you guys. Buddy, seeing the screen here?
Yes, sir.
Yeah. Let's see. So we have a compulsory topics in chemistry here, guys. Right. So these are, and then I'm trying. Well, in terms of labs, we have to make sure that we cover these. So now, if you notice that in the last class we did test for anions, we still have the test for cations to do, and perhaps maybe a test for a few well, test for anions and cations. May just do cations in the interest of time. Not sure what's gonna happen there. But we have organic chemistry. If we're going up this list, organic chemistry would be necessary as well. Now this going to be a problem because, well, based on CXC requirements here, we should do this is actually a face-to-face type of lab though. So it's going to be very difficult to do this at home. Unless we get really creative. All right, let me see something. Could really get creative here with organic chemistry. So that will give you your final P and D. So let's do a little check here. So and see if I can use. All right, so probably black here. All right, guys. So we did anions there. So and having sachet there as well. All right. So we did this one here, and this is what we're gonna do today. Acid base and salt. So this will carry us to lab 7, and we're gonna need one more P and D that we can carry out. So this is our P and D lab here. So looking at acid base and salts today, guys, and we're gonna have, well,
Is that last P&D, sir?
no, it's not the last P and D. How many P&Ds you have?
Sir, about 2 we get, sir.
Two,
Two?
sir.
Two
Yeah.
P&Ds? You get two P&Ds. That's interesting. Two. Wait, hold on. Which one? Which one? Which one? I know you get the separated one. Which other P&D you get?
Like this guy showed too much of them. Yeah, but not plus.
Do you remember? I don't.
Sir, I have to check.
I really want to know though.
It's a PND.
I think I one PND.
Oh, because
Last time.
The separation one.
that's the only P&D that's no that I gave you guys.
Yeah, sir, I thought it was going to be 3. Maybe I mixed it.
There are gonna be 3, but you don't get 3 yet. You have 1 now. And that includes for Kimberly and Sachet. They would all right. So we only have 1 P&D, and we're gonna do another one today. And it's important we get those off because those tend to you need more help with those. All right, so we want to get that out of the way. So that's what we look at, acid base and salts, but bear in mind that we still have oxidation and reduction. Electrolysis, don't think we did anything on electrolysis in terms of, and I can't find any virtual experiments for electrolysis, so that's quite unfortunate. And so these are more face-to-face type labs, and that's what's holding up the progress for us right now. But then for organic chemistry, we could go. This is another PD with alcohol, so could just run off these 2 then. That will carry you guys to 8, and then once you have 8 labs, then all right, then we at least we have something. 8 labs will carry us to the minimum that we can stop doing labs with. You'd have 4 P&Ds, so you'd actually have 3 P&Ds as a full quota, and of course the other labs could add up to the 8. So we would be in good standing there with 2 more labs. And but then in terms of syllabus coverage and the exam now, we want to cover labs from these areas. This is if you don't cover labs from these areas, the exam might be challenging, or more challenging than it needs to be. So bear that in mind, guys. So yeah, we're going to have a look at acid, base, and salt today. So let's just get ahead with it now. All right, so 9 persons here, enough to start with. You know the procedure. It's just like the last P&D, guys. It's the same format here. Of course, you put your name here, but let's put today's date. Today is the 19th of the 4th, 2021. All right, as well as today would be lab. Well, depends on Kimberly, which number lab this would make for you?
8.
Okay, I make it 8. So all right, good. So also be 8 for Sachet. So and then it will be lab 7 then for everybody else. All right. So this is it now, guys. Topic is acids, base, and salts. And let's read through this problem statement. We have Benito and Deschanel were discussing the vitamin C content of various fruit juices. And Deschanel was adamant that grape juice will have more vitamin C than orange juice, but will have actually less vitamin C than pineapple juice. So let's put in less here. All right. And you're supposed to plan and design an experiment to test the claim. All right, guys. So now, one thing you want to learn right now, right? And learn this now and forevermore, that vitamin C is an acid. All right, vitamin C is an acid. Now, does anybody remember what makes a substance an acid?
As long as it donates oxygen ion, I think.
It all right.
They
All right, so,
contain hydrogen.
all right. Before you answer, Jenna, Kimberly, what did you say before that?
So I said it's an acid because acids usually donate hydrogen ions.
Okay. All right. And Jenna was confirming that you said that it contains hydrogen.
Sir, they are electrolytes, sir.
Well, yeah, but that's not telling me that it's an acid generator. So the matter at hand is what makes it an acid is that it contains a hydrogen ion in it. Everybody get that? All right. Now
Yes, sir.
we look at acids before, and we also said what was common with all acids. So let's see vitamin C. I want to probably see the formula for vitamin C and sort of explain or see where the replaceable hydrogen would be. All right, so all right, there we go. So it's vitamin C, and I have Daniel here. So some persons having internet issues here. All right. Anybody experiencing internet problems today?
Yes, sir, Frandy, yes, sir.
Yes, sir.
Gosh. All right. Well, guys. Well, let's look at this interesting.
But our JP is currently gone, sir.
Yeah. So there are problems there with once the current have problems, the internet will have problems because them feed off of the power line. Internet need power to operate. Everybody seeing this?
Yes, sir.
Yes, sir.
All right. No, okay, so what we have here is what vitamin C structure look like. Very complex structure, but between where it has carbon, hydrogen, and oxygen, and you should be able to predict what type of bond will exist between those elements. Anybody want to tell me what type of bond you expect to happen there with carbon, hydrogen, and oxygen in there? Is there any metal present in that compound?
No, sir.
No, resounded no. Most persons not sure. That
No,
should indicate.
sir.
Oh, okay. All right. So we are agreeing that then what we're looking at here is this, and let me just point out because some person easy to think that this thing is complicated, but it's not. Simple stuff here. All right. Looking at the formula of the compound, we don't see any metals in this formula. Because you should all know what C, H, and O represent. All right. No. So that's pretty much vitamin C. That's the same vitamin C you find in your oranges and and what you take, when you're having cold and flu, that type of thing. So no, what this is showing you is it's actually the bonding here in vitamin C. And what we're seeing, all right, so let's put in the correct labels here because this red circle represents carbon, and then this blue represents oxygen, and of course this gray thing here represents hydrogen. So it is telling you how it is bonded. One of the things I like with this model, it's something that in a face-to-face class, and so you could actually make a model of it and see how it really set on a microscopic level. All right. Just like how if you were to look at what makes you unique, it's a simple thing called DNA. Everybody hear about DNA before?
Yes, sir.
All right. So did you know that DNA is also an acid?
No, sir.
No,
No.
sir.
All right. So what does the A stand for in DNA?
Deoxyribonucleic acid.
All right. So the thing is, DNA stands for deoxyribonucleic acid, as Kimberly is reiterating, and so DNA is an acid. So we're gonna see how important acids are, and ascorbic acid is here as one of those examples here. But then you wanna also notice, and this is actually in organic chemistry. We're well with organic chemistry here. We're just dealing with carbon, hydrogen, and oxygen. So this lab could actually double as an organic chemistry lab. However, we're going to treat it as an acid, base, and salt type of situation. Notice we are on acids now. We'll soon look at bases, but definitely acids just have that replaceable hydrogen. So see the hydrogens at the end of, so this is how it will look like in real life, guys, right? This will be, if you were to see it from a microscope, it would look like what you're seeing with the circles here. All right, remember the red circles are carbon atoms. All right, the blue ones are oxygen atoms. All right, and of course the gray ones are actually hydrogen atoms. All right, and how we can know them easily is that, okay, carbon, because carbon is in group 4, carbon can form 4 bonds. It can actually form a quadruple bond here. So it forms 4 bonds. So if you notice, this red circle is connected to 2 hydrogen atoms, 1 other carbon atom, and the oxygen. Everybody seeing that? This red circle here.
Yes, sir.
All right. So what it's actually doing here is sharing electrons with these. All right. So and because I now if there are no, it's actually covalent bonding because there are no metals present there. So covalent bonding here. All right. Now, so the hydrogen that it has, it's on the outside, and because it's on the outside, it's replaceable. As a matter of fact, with vitamin C, you could actually replace, well, this one, anyone beside oxygen will be held on tight. So, like for example, this can replace, because oxygen have it. So it pair up there. But this one is alone. This hydrogen is alone. So this is what we call a replaceable. Any hydrogen that is like by itself, that's not bonded tightly with another element, is replaceable. All right, so that's the idea here. The hydrogen here is replaceable. All right. So I guess if you look at it in terms of a Beyonce situation, right? You know, this is certainly irreplaceable. Replaceable, I should say. All right, so let's just go right that. All right, so what it means, guys, that when ascorbic reacts, ascorbic acid reacts, or when vitamin C reacts, which is the same thing, this hydrogen is replaced, and that's what causes it to react. So how we know when this react is that, well, maybe you put it in water and it start to fizz, just like when you're making your reduction. Anybody know reduction?
Yes, sir.
Yes, sir.
Yeah, definitely. The acid is activated when it's placed in water. So yeah, that's the active ingredient in reduction. So all right. So the point is, what we're looking for in this experiment is fruits that contain that substance, ascorbic acid. And you're going to run a test there for that. Let's see what happens here. Uh First hypothesis is saying that what pineapple juice has a higher vitamin C content than orange juice and grape juice. The question is, how do you test for acids overall? So who,
Sorry to use litmus paper.
yeah, okay, so you mentioned litmus paper because we would have done that from the previous lab. All right, so yeah, definitely litmus paper is useful there. Very useful there. So let's look at all the tests for acids. All right, so acids. All right, so acids can be tested and qualitatively. This is the language of chemistry, qualitatively using litmus paper. All right. In fact, we're gonna use blue litmus paper. All right. We have 2 litmus paper that we tend to use here, and blue and red. But blue is used to test for acids. However, to test Yeah, so we also use. All right, we can also use universal indicator. Use universal indicator. Or yeah, or pH. Okay, it's pH paper as well. Or pH scale. All right, so there you go. So pH scale. All right, so these things are important. You see, you expect every student that do chemistry to understand these things. All right, underlining these. Very important now. All right, so this now, if we go back to the problem of this question, guys, we want to test which one has the most vitamin C between these three. If you have any other juices, you could probably use them if you have them at home. So, and when we talk about juices, we're not talking about one of them where you buy on the shelf or we call juice. Because what people call juice is not juice, it's a mixture of some water and some other stuff. Juice comes from the real fruit. So if you have pineapple juice is from real pineapple, right? And orange juice is from the real orange, right? And then grape is the same thing. So when I test the vitamin C content of those, we're going to have to get the real thing. But you understand that?
Yes, sir.
So no, because you go and you see the box say pineapple juice, it's pineapple juice. No, that's a marketing strategy. That's almost like a scheme, that's like scamming because they legally, yes, them get the right to put pineapple juice on the box or on the bottle. If it has certain percentage of pineapple juice in there, and so that's what the law allows them to. So when people reach and in the business of making money, government say, all right, you go and pay me a tax, but then I will make the laws work in your favor so you can pay me the tax and you can make some profit, win-win. But pineapple juice is not pineapple juice, you know. And then yet when if you decide to get mischievous and call somebody overseas and tell them say them win something and then them for send them credentials come and something and then you decide say you are go help yourself with some cash from out of them account or something or thief them credit card, well, you're a scammer if you do that. But then when these people say, all right, I'm just going to put 1% of pineapple juice in one bottle, 99% water and sugar, and you sell it as pineapple juice, yeah, you're actually you're illegal there. You're doing something great because one thing them say, well, you're providing employment for people. You're selling something which can be exported. All of a sudden, you're a saint. So, so I don't know what the laws are saying here, but point is that not all juice is juice. So, as a chemistry student, um, maybe some of you might get more advanced later on. Juice is not really juice. You're gonna have to test the juiceness or the real percentage of juice in these things. All right, so pineapple juice um is one thing you can use, but then all right, fine. So as Kimberly was saying though, you said something about litmus paper being used to test. It does test whether or not it has it qualitatively. So when you have blue litmus paper, let me show you what that look like though, because maybe some of you might not you know might not know what it look like. And let me just show everybody what it looks like. All right, and here we go. All right, everybody seeing this?
Yes, sir.
All right. So as according to this image, if we can even zoom this image, all right, red litmus. turning. All right, so let's forget about the red litmus, because the red litmus tastes for base. So we're focusing on the blue litmus now. And let's just look at it. This is what litmus looks like, a piece of paper that you put. All right. So blue litmus turns red in an acid. And that's just qualitatively telling you what that is. All right, maybe this is a better image. That one kind of blurry. And just remove that one. All right, so this is blue litmus turning red in an acid. All right, of course. We have other stuff that we can use as well. Just point it out to you. Yeah, right here. All right, so as a general rule, this is how you deal with the acids. And litmus paper. All right, no, that only tells you now. This only tells you whether or not we have an acid, but what tells us the strength of the acid now? That's the other thing. Now, and this is where other stuff come into play here. So we're looking at pH scale, or rather pH paper. Yeah, let's look at pH paper and see what that look like. And what the how this pH paper work now is that you get a sheet of paper and you dip it in a liquid if you want to test what it really is. And then something like this they use for urine test. So if you guys ever do a urine test or see how it is done, well, they use a little strip of paper, put it against some color coding, something like this, right? So this is the pH paper. And it's actually the pH paper scale. So you just basically get the liquid, put the paper in it. This orange paper, this is actually the pH paper. And of course, this part was actually placed in some solution and it changed to this color, which you call it an orange or red. And then this will tell you that's an acid, but it not only tell you that it's an acid, it tells you how strong it is. So remember now that this scale now, strength of acid now works like this. Here's the strong
pH
acid.
What about pH 7, sir? Now let's hear something about that now.
Well, forget about that. This will focus on general. pH, yeah, so looking at the strong acid is about right here. Right, strong acid carries you up to about 2. All right, then from about, all right, so between 4, 5, and 6 now, these are weak acids. And then that's all we need to know right now. Strong acids, as we say, guys, strong acids go from, well, let's put it at 0 to 2 then. All right, 0 to 2. Strong acids. Now, question is, what is the pH of ascorbic acid? No. How strong is ascorbic acid? All right, no. Let me see now. And we want to have an idea of how much and how the strength of the acid now, guys. You see this pH scale? Anybody know what pH stands for?
pH, sir.
Yes.
I think like the acidic.
What does P stand for? What does A stand for?
Oh,
Sir,
Yeah.
potential hydrogen.
Oh, just came early. We're quite sharp tonight. Potential. Yeah, very good. Of hydrogen.
potential hydrogen.
Yeah. So that's basically it. All right. So, in other words, the pH tells you how much hydrogen is present there. That's it. There are some mathematical calculations to work it out, but just as a whole, the smaller the number is, the more hydrogen it have there. That's pretty much it. All right. If you look at it this way, potential means what? Potential means there's ability, no so? Right? Substance All right. No, the pH really tests like it does testing the concentration really, how much hydrogen. So if you have a whole heap of hydrogen, it means that the substance doesn't want any more hydrogen. So therefore, if a substance is full of hydrogen, it's gonna have a pH of 0. All right. If it have, if you don't have as much as 0, it could be 1 or it could be 2. But these is telling you that the substance has a lot of hydrogen ions. Right. So let me write that here so that you remember that. Strong acids have high hydrogen levels. Not just hydrogen, but replaceable hydrogen ion levels. So like the acids going to have a whole heap of hydrogen ions present. And example of these, there are some example here. Your strong acids them. Anybody remember the strong acids them?
Sulfuric acid.
Yeah, definitely sulfuric acid is one. Which other one?
Ethanol.
No.
Phosphorus, sir.
No. No.
Gastric acid,
What is gastric acid?
like acid that is found in the stomach or something like that.
Yeah, but chemistry people don't call that gastric acid. Give me the chemistry name for it.
I don't know the chemistry name for it, sir.
We did it. We did it already.
I don't
Hydrochloric
remember.
acid.
All right. Well, Tarshay, what's that? What you saying there?
I was saying hydrochloric acid.
Yeah, that's hydrochloric acid is one of them, right? That's the correct name for it. The acid in gastric juice is hydrochloric acid. So let's go write that down. All right. Yeah, which other one?
Sir, what about ammonia?
No, ammonia is not an acid. Ammonia is not an acid.
Nitric acid.
Yeah, nitric acid would be the third here. All right, when we talk about strong acids, these are what we look for. All right, if you want to get into details, sulfuric acid formula is H2SO4. Hydrochloric acid is HCl, and nitric acid is HNO3, and the hydrogen at the ends there are replaceable. So that's the story here. So strong acids them have high hydrogen ion levels. All right, which means that it'll give up with a hydrogen there. All right, so that covers that. Now let's look at ascorbic acid pH now. This is something that you can drink. So and then some of you guys get an upset stomach when you drink too much acid. So let's find out why. Because soda is also acidic, but different acid in soda. All right. But let's
Sir, I
just
heard
see.
that. So, sir, somebody there tell me one of my friend in there tell me say carbon dioxide they contain.
Well, yeah, that's partially correct. Yeah, but partially correct in the sense that let
But
me
sir,
see
I
here.
never believe him, sir, at first.
Yeah, but that's a partially correct statement. The carbon dioxide in soda is actually dissolved in water, so it forms carbonic acid. Let me just find out this. All right. Well, we need to. Well, actually, it says here. Well, it actually has the pH there. They're actually saying that it's actually I'm say depend on the percentage though, and I'm saying it's 2.5 here. So it's between 2.2 to 2.5. Let's see. All right. They actually have It's on Google though, but I don't like how they present the information. So let's show you what it on Google says here. All right. Yeah, definitely the L-ascorbic acid is telling you the left-hand orientation of it. But ascorbic acid is freely soluble in water and don't dissolve in alcohol, insoluble in chloroform, ether, and benzene. All right, so that's not important. Just know it's soluble in water. Very soluble in water. Forms a colorless, slightly yellow solution, has 2 pKa values. All right, this something that you're going to learn.
So strong acids can melt metal or something.
Not all of them. All right. So the pH of 5% with volume solution is 2.2. All right. So right here now, yeah. So it's about 2.2 to 2.5. So let's highlight that ascorbic acids around that. And how do we get this in the color there? Right. All right, guys. So that's what we're looking at. The only way we can figure this out again, and it's a 5% solution. That means that you need you need 5% of pure ascorbic acid. However, you're going to get that acid though from this experiment is from the fruits. Then we're going to have some limitations as well. So we're going to talk about that. All right. So that's acid, guys. So far you should at least know that we don't really need to know the formula really, because just know say all right, it's an acid. pH is, and let's put the pH here. pH is equal to 2.2 to 2.5. This is going to put it on the slightly strong side. By the time you touch like 3, I mean, it's not going to be that, not going to be that strong really. All right, see the information here in the theory though, it says that it's a weak acid, so it puts it on the weak side. It's only slightly stronger than vinegar. As well, vinegar is another acid. When dissolving water, vitamin C is sour but less so than citric acid, which is found in lemons and limes. Chemical formula is C6H8O6. And let's look at this chart here, guys. Everybody can see this chart, this list here.
Yes, sir.
All right. So this is actually comparing the different fruits now and how much citric acid it have. As you see in here, which one looks to have the most in this chart?
Is there?
Yeah. Which one of these? Which one of these fruits tend to look like it have the most?
Cashew apple, sir. Because it's
Okay.
a vitamin C is acid.
Yes.
So, and you say per milligram 100 milliliter. So a cashew apple would have beat, sir.
Cashew apple. Everybody know what cashew apple look like?
I don't have a clue,
Yes,
sir.
sir. It's yellow.
It's yellow. Yeah. The cashew apple are they see at the top part of the cashew nut, I mean, the fruit they come with the nut. So let me see, show you what it look like. I can't believe I only never say cashew before.
No, sir.
My God.
Only one in the plastic chips.
You see in the this is what cashew looks like, This is cashew.
That's
So
how big it is, sir.
yeah, so this is the part that you eat as a the part you eat as a nut. Yeah, this is actually the fruit. So that's cashew. It's cashew. So the fruit part, cashew actually it's related to mango. It's in the same family as mango.
Mm.
Yeah. Yeah, so mango is in the cashew family. So, and I've tasted the cashew fruit and I can taste the resemblance actually. It's pretty close.
So,
Well,
sir, you can eat the
Really,
fruit
sir?
also.
is that?
Sir, you can eat the fruit also.
Of course you can eat it. Now, that's why a fruit, you can eat fruit. Then cashew apple have the most vitamin C out of all the fruits.
Those things are only nut alone.
Hold on.
Those things are the only nut alone.
No, you eat you the thing about it is they're not going they hardly going to sell you hardly going to go in the market and see them and sell cashew fruit. They make cashew juice though. But I never see them selling the fruit.
I think they come now on shells, sir. I never know say a fruit they hang off.
Well, here's the shell. I mean, here's the shell. The shell is here. So the shell grow and after the fruit bear. So when you see the tree now, you look at the tree, you see the fruit, and you say, all right, if you want the fruit, you can just eat the fruit and forget about the nut here. But if you look at it closely, it's this is where the mango evolved from. It evolved from this plant actually. Um the mango now is an evolution of this where the where the fruit evolves in the shell. So if you notice, this have a mango shape here, shape like some mango. So they're actually related. A lot of people didn't know, and it's sad though that Jamaicans don't know which fruits are related. But certainly this is a, as we say, the reason I bring this up is that on this list, cashew happens to have the most vitamin C. All right. Of course, followed by black currant, which is some small looking grape thing. Anybody ever see black currant yet? Really know
No,
grow in
sir.
Jamaica. Yeah.
Yes, sir.
Sir, is that the proper
Okay.
name for it?
What currant?
Black currant.
Yeah, that's the proper name for it.
So you not have no nickname.
People call it grape. In Jamaica, them call it grape. Them see it as grape. They look like tiny grapes.
Oh, I think so.
Yeah.
So I've never seen it before, sir.
All right, black currant. All right, black currant. No. All right. This lab as it is, I actually did it. We did it twice up at IPAS, and it was well, it was a long lab, but it was very successful. Because we had to do a lot of we have to matter the fruit, then we had to get distilled water and dissolve some of make the fruit juice drain off in there, that kind of stuff. Very long lab. It was interesting though. But all right, let me show you what black currants look like. I mean it could pass for grapes, but it's not really. It's probably in the same family as well. Yeah, it's in the same family, berry family. But it's that's what it looks like, black currant. And they sell it in the
Oh, I
supermarket.
see it before, sir. Oh, I see.
Yeah, they sell it in the supermarket. Sell it in the supermarket, like well, and not any supermarket, like Shoppers Fair and probably Mega Mart. But I haven't seen it in other supermarkets outside of those. And so, all right,
Sir,
so
I
that's
know
black
about the,
currant.
the dried ones.
The dried ones.
Yes, sir.
Oh, okay.
The ones that you bake.
Oh,
The ones that you bake with.
you talking raisins?
No, currant.
Dried currants.
They have the dried
Oh,
ones.
you mean prune?
No,
Interesting.
it's the dried currant. They have prune and they have currant.
Interesting. I wonder how that tastes, because black currants taste sour, you know, because vitamin C.
It's sweet too, like the prune.
Oh, okay. when them dry toast, that means them get rid of the water and just leave behind the sugar in there.
Yes.
Mm.
People bake with it.
Yeah, I would imagine that well, actually people are saying, well, it has been known for a long time that black currants are healthier than grapes. Grapes are European, currants are American. Grapes used to make wine, whereas currants are usually eaten. Maybe they make wine with it, but it doesn't have it don't give it the flavor like grapes. And then, on the other hand, grapes have other things that currants don't have as well. So that's why grapes kind of more even though it's ranks here, look at where grapes are. Grapes way up on the scale here, 45 out of 100 here. But black currants have 215 for every 100 milliliter. This is saying that it has more vitamin C than even the water that is in the fruit, which is amazing. So but look, in Jamaica now, we go for the orange, especially in the flu season, the COVID time. Oranges are preferred. Orange is actually 54 out of 100.
Yes, sir. Orange, apple, and banana, and something.
Right. So these up here are more Jamaican. Strawberry are more temperate climate. Strawberries grow out here as well, but them expensive, man. Of course, kiwi. Everybody should know of kiwi fruit.
Yes, sir.
Yeah, it's them sell
Yes,
it in.
sir.
Yeah, but I'm not a fan of it. I like the juice, but I don't think I like the fruit.
Sir, I think you kind of look hairy on the outside.
Yeah, look like the actual animal, which is called the kiwi, which is hairy. So yeah. All right. So yeah, all right. So then, all right. So we started to run out of time, but then I just wanted to understand what vitamin C is all about. Next class we're going to we're going to look at how we can test, how we can determine how much acid is in a substance. All right, that will take us into some other tests. All right, once you learn how to do that and probably see a demonstration of it, then now you would be able to write up this lab properly. All right, so I'm teaching you acid and bases through this lab, and then you write it up. All right, so you can go and do extra research, guys, do extra reading and how we test for this trend. Well, in this case, how we can test which one of these have more acid. The hint is that it's in the concentration of the vitamin C. So when you have to learn how to work out concentration, yeah. Let me just write that down here though. All right, let me write it down and send this lab to you. All right, so key topics here. For lab, and this is lab number 7. All right, so acids, bases, pH, scale. All right, neutralization. You have the indicators, and of course introducing it to this word. And of course, concentration. All right, and that's it. Concentration. We have molar concentration. All right, so these are terms that you're going to have to read up on, know these before you can think about carrying out this lab. All right, any questions here?
No,
No,
sir.
sir.
All right, so this is what, right? So when discuss these things, read up and discuss, read up on these, get some definition for these. All right, and then we're going to discuss them next class. All right, before we can go any further with this lab.
Okay, sir.
All right,
All
yeah.
right.
All right, guys. So thanks for coming out, and I'll see you guys on Wednesday.
All right, sir.
Yeah, all right.